Hi YouTubers, this is Engineer Gerard, and I want to show you a little thing that I'm building today. Um, a lot of times when a well first gets developed or first gets drilled, no one really knows how much water it can output and at what rate and for how long. So oftentimes a pump test is required. And I started looking into these pump tests, and they're rather expensive things. And the sort of well system that my wife and I wanted, um, it didn't need to have a real high gallons per minute or liters per minute or anything like that. So we only needed to test at some very small fraction of what even a professional well pump tester could test at. And so we're looking at ways to test this, and there's some even simpler methods that are called slug test, where you rapidly introduce or remove a certain amount of water from a well and see what the response looks like, if it fills in really fast or fills in really slow, and it can give you an idea of how much output the well can have. But I wanted to get a little more direct answer and sort of get an answer in the range that my wife and I were looking at. And we were kind of looking at trying to get an output about a half a gallon a minute. And we have very large elevation changes and we have relatively deep wells. So kind of the solution that we've come up over the years is that we pump at very low rates into holding tanks near where we need the water. And that way we can use much smaller pumps, and they're much less efficient, or excuse me, they're much more efficient, and they less current draw and that sort of thing. But anyway, so this is an example of a device that I'm using or I'm going to attempt to use to test the output of a well. And what it is one of these little inexpensive spray pumps, 12 volt. They're used in agricultural systems. It's small enough that this would fit into a 4.5-inch diameter well. It has a maximum output of 70 psi, and at that point it will cut off. Let me show you my light here a little bit better. Hard to tell. That red object there at the bottom, that's actually the pressure switch. And so I initially tried configuring this where I would directly have elbows plug into the 3/8-inch NPT ports, but it ended up making the device too large a diameter to fit down the well. So what I did is I took some, well, I guess this is 1/4-inch polyethylene drip tube with no perforations in it. This is solid. And I calculated the burst strength on it. It's somewhere in the neighborhood of 450 psi. So it shouldn't give me any problems, at least in the realms that I'm working at, and besides the pump will cut off at 70. And what I did is I rig it up to this sort of flotation column, and that way the pump never has to actually ever get in the water, so I don't need a fully submersible pump. Now these pumps do have a degree of waterproofing in and on and around them, but they're certainly not submersible. And so you can tell from the light here, I rigged for the for the intake, and I drilled a little hole in the side there and glued the drip line in there, and then for the that is the intake. That's right. And for the output, I did something very similar, and it made it pointing upwards so that it kind of runs up the side of the motor there, and it'll eventually go way up, as much as 100 and I forget what I calculated it as, but well in excess of 100 feet up the well. I have not used a Moody friction chart to determine what my friction losses are going to be through this, and they're probably going to be pretty high. Static test today, as a static test, a test with no elevation change, so no, I'm not trying to pump it up a hill or anything, just laying on the ground, sticking one into a container and the other into another container to measure its flow rate. It produced about 3/4 of a gallon a minute, and that's a little less than half what's claimed by the pump.